Welcome to a Simpson's rule example. So recall, we had our formula for Simpson's rule, which said that the definite integral from a to b of f of x dx was approximately delta x divided by 3 times f of a plus 4 times f of x1 plus 2 times f of x2 plus 4 f of x3 plus 2 f of x4 plus plus 2 f of x and minus 2 plus 4 f of x and minus 1. And then we end with plus f of b and close our brackets. So that delta x over 3 is multiplying that entire thing. Where delta x is b minus a divided by n, and xi is a plus I times delta x. Here, n is the number of subintervals. So we found this formula in the previous video. Wasn't the most pleasant thing to find, but at this point we can just work with the formula. So our job is to approximate the definite integral from 0 to 4 of e to the negative x squared dx using Simpson's rule with 4 equally spaced subintervals. So 4 equally spaced subintervals, that means our n is equal to 4. We have our a is 0, since the lower bound of our definite integral is 0. Our b is 4. Our f of x is e to the negative x squared. Let me update my screen quickly. So we need to find our delta x, find our xi's. So our delta x, we are looking at delta x is equal to b minus a divided by n, or 4 minus 0 divided by 4. So we get our delta x is 1. The next step, we have to find our xi for 0 less than or equal to I less than or equal to n. So our x0 is a, which is just 0. x1 will be that plus our delta x, or 1. x2 is that plus delta x, or 2. x3 will be 3. And x4 is 4. Our next step is to find all of our f of xi. So we have f of x0, or f of a, is e to the negative 0 squared, better known as 1. F of x1 is f of 1. Actually, f of x0 I'm going to leave as f of 0, which is 1. F of x1 is f of 1, or e to the negative 1 squared, better known as 1 over e. F of x2, we are looking at f of 2, or e to the negative 2 squared, better known as 1 over e to the 4th. F of x3, we are looking at f of 3, or e to the negative 3 squared, better known as 1 over e to the 9th. And finally, f of x4 is f of 4, or e to the negative 4 squared, better known as 1 over e to the 16th. At this point, we have all of the numbers that we need. So now we can go ahead and apply Simpson's rule. So we have the definite integral from 0 to 4 of e to the negative x squared dx is approximately equal to delta x over 3. Our delta x was 1, divide by 3, times f of x1, f of x0 plus 4 f of x1 plus 2 f of x2 plus 4 f of x three plus f of x4. This one's a short one. We are only doing 2 parabolas. Plugging in, we have that this definite integral is approximately 1/3 times, in brackets, 1 plus 4 times 1 over e plus 2 times 1 over e to the 4th plus 4 times 1 over e to the 9th plus 1 over e to the 16th, end brackets. Plugging this into a calculator, we wind up getting that our definite integral is approximately 0.83621 ... So Simpson's rule, this was with 4 subintervals, takes a little time to plug in, but ultimately it's not really any more work than the trapezoidal rule or using Riemann sums. You just have to calculate all of those f of xi's. In the next video, we'll go ahead and look at sort of the expected error we can get from the trapezoidal rule and Simpson's rule.